Okay, today's lesson 4.4 entitled Ratios in Pi. In it, we're going to learn the relationship between circumference of a circle and its diameter. A circle is a set of points in a plane that are a fixed distance from the center. So this is one of your vocabulary words that you're going to need to know. A radius is a line segment with one endpoint at the center of the circle and the other endpoint on the circle. The length of a radius is called the radius of the circle. Over here in the diagram, the radius has one endpoint in the center and the other endpoint on the circle. So notice it's halfway across the circle. A diameter of a circle is a line segment that passes through the center of the circle and whose endpoints lie on the circle. The length of the diameter is twice the length of the radius. The length of a diameter is called the diameter of the circle. So in this picture, the diameter has to go through the center, and both endpoints lie on the circle. Okay? The circumference of a circle is the distance around the circle. So the circumference is the distance all the way around the outside of a circle. We're going to be determining proportionality in circles. The ratio of circumference to the diameter of any circle, this is C over D, circumference to diameter, of any circle is the same for all circles. This ratio, C over D, is represented by the Greek letter pi. Okay, and the value of pi is close to 3. You can approximate pi as 3.14 or 22 over 7. In example 1, we're going to determine if the radius and the diameter of the two circles are proportional. So in example 1, it tells us the radius of a larger circle and the radius of a smaller circle, and we are going to see if they are proportional. Well, in the information they gave you above, remember it tells you that the diameter is twice the length of the radius. So in the first circle, it tells us that the radius is 5. Well, the diameter is going to be twice that, so the diameter of the larger circle is going to be 10 inches because 5 times 2 is 10. In the smaller circle, they tell me the radius is 3 inches, so my diameter is going to be 3 times 2, which is going to be 6 inches in the smaller circle. And they remind you right here that the diameter is 2 times the length of the radius. Okay, so now that we know our radius and our diameter of both circles, now we can go ahead and set up a proportion using the corresponding lengths of the radius and diameter. And our proportion is going to be radius over radius equals diameter over diameter. So we can go ahead and label that our larger circle is going to be circle number 1, and our smaller circle is going to be circle number 2. So notice in the large circle my radius is 5 inches, and the radius of the smaller circle is 3 inches, so I put 5 over 3. I'm setting up my proportion. Now I need both diameters, but I need the diameter of the large circle first. That's why these words are so important. So the diameter of the large circle is 10, and the diameter of the smaller circle is 6. So I'm trying to determine if these two are proportional. Well, remember, in order for this to actually be a proportion, these two ratios have to be equal. Well, notice that if I simplify by dividing by 2, 10 divided by 2 is 5, and 6 divided by 2 is 3. So this side is equal to this side, so they are proportional. Okay? In the reflection, it says in every circle, what is the ratio of the radius to the diameter? What is the ratio of the circumference to the diameter? So notice that they're first asking for the ratio of the radius to the diameter, and in ratios, the order matters. So we have to put the radius first and the diameter second. Well, remember that the diameter is twice the radius, so that's a 1 to 2 ratio. And then the ratio of the circumference to the diameter, you can write it like this, C over D, is equal to pi. Okay, they gave us that information up above. So it says, drawing conclusions. Based on the ratios of the radius to diameter and circumference to diameter, are all circles proportional? That's the question they're asking us. Are all circles then going to be proportional? Then the second question is the ratio of the circumference to the diameter of any circle the same for all circles? The ratio of circumference to diameter, is it the same for all circles? Well, I want you to write that all circles are proportional since corresponding lengths are always proportional. And I want you to write the ratio of C over D, that's circumference over diameter, of any circle is the same, that's supposed to be an A, for all circles. And it's always going to equal 3.14. Okay, so the ratio of C over D is the same for all circles. It equals pi, 3.14. Okay, now it's going to be your turn. You're going to determine if the radius and the diameter of these two circles are proportional. So remember the information we talked about with the relationship between diameter and radius, and remember the way you're going to set up your proportion. Okay, pause your video. Okay, so here's my proportion. It's R over R equals D over D. That's radius over radius equals diameter over diameter. Okay, and again, we're talking about circle number 1 and circle number 2. Okay, we're going to have our large circle be circle number 1 and our smaller circle be circle number 2. Okay, and that way you are sure that you set up the numbers correctly, so you'll get the proportion correct. So the radius of the larger circle, circle number 1, is 8 feet, so you should have put 8 over the radius of the smaller circle. Well, they didn't give you the radius. Remember that whenever it goes through the center and it's all the way across, they gave you a diameter. So the 9 is your D. You had to find your R. Well, if the diameter is twice the radius, then to get the radius, you just take half of the diameter, which would be 4.5 feet. Same with the larger circle. They gave me my radius, that's my R, and we need to get the diameter ourselves. Well, it's the whole way across, so 8 times 2, that would be 16 feet. Okay, so I would have 8 over the radius of the smaller one is 4.5. And I'm trying to see if it's proportional with the diameter of the larger circle has to come first, so the 16 should have gone on top when you set up your proportion. And the diameter of the smaller circle should go on the bottom, which is the 9. And you're trying to see if these two ratios form a proportion. Well, in order for them to form a proportion, they have to be equal. You could do this a couple of different ways. You could simplify this, or you can notice that what would I have to do to 8 to get 16? I would have to multiply it times 2. If you do the same thing to the bottom, is 4.5 times 2 9? Yes, it is. And that's how you know when you do the same thing to the top as you do to the bottom, that's how you know that, yes, they are proportional. Okay, on the back of your notes, we're going to talk about finding missing parts of a circle. So you know that C over D equals pi for all circles. We're going to use this ratio to find unknown measures, C over D, okay? So in example number 2, the circumference of the larger circle is approximately 94 centimeters. They want us to use a proportion to find the circumference of the smaller circle. So on this one, we are going to set it up a little bit differently, because notice in the last one it was R over R equals D over D, but this one is C over D equals C over D. So this time, instead of setting up the proportion horizontally, they've actually set it up vertically. So instead of putting our words over here to the side like we normally do, I'm going to have you go ahead and put large, that's for the large circle number 1, and small for the small circle number 2. So up here we're going to label this is going to be circle number 1, this is going to be circle number 2. Okay, so I need the circumference of the large circle, and they told that information to me up here. It's 94 centimeters, and I'm going to put that over the diameter of the large circle, which happens to be 30. And I don't know the circumference of the smaller circle, so the C is my unknown, my variable standing for my unknown. That's what I'm trying to find. And I need to put that over my diameter of the smaller circle, which is 15. Well, again, here I could use the shortcut. Okay, I could say, well, I see a relationship between these two. I know that 30 divided by 2 is 15, so I know that to get the circumference, all I have to do is 94 divided by 2. And if you needed to go do some math over here, 2 goes into 9 4 times, which is 8, subtract, bring down. 2 goes into 14 7 times, exactly. So my circumference of my smaller circle is 47, and that is centimeters. That is how you're going to find your missing values. In example B, it tells us that a larger circle has a circumference of 50.24 centimeters and a diameter of 16 centimeters. And they tell us the circumference of a smaller circle is 25.12 centimeters, and they want us to use a proportion. This time we are finding the diameter of the smaller circle. So again, notice it's set up vertically. So I'm going to want to put large, small. Okay, so in the large circle, our circumference was 50.24. And they told us the diameter was 16. And in the smaller circle, its circumference is 25.12, and we don't know the diameter. So my D stays there. That's what I'm looking for. So again, I notice that, oh, if I divide 50 by 2, I get 25, and if I divide 24 by 2, I get 12. So that's the relationship here. It's divided by 2. So in order to find D, I could do the same thing to the bottom. What is 16 divided by 2? That diameter is going to have to be 8 centimeters to make that proportional. All right, on the your turn, you're going to do the same thing, but you're going to be finding this way, this proportion, C over D equals C over D. So pause your video. Okay, so on this one, it says that the circumference of the larger circle is 44 meters, and the smaller circle, the circumference is 11 meters. So this time, you're using a proportion to find the diameter of the smaller circle, and this one has a picture. So you could go ahead and say, okay, well, circle number 1 is my small circle. Circle number 2 is my large circle. Okay, it's a good idea to always label those. And so again, we're working vertically. So the large circle has the circumference of 44 and the diameter of 14. And the smaller circle has a circumference of 11, and we're looking for the diameter. Well, I can't use the shortcut, because even though I could do 14 divided by 4, I could do 14 divided by 4, but it's not going to come out exact. So you should know that you don't, if the shortcut doesn't work right away, or you're going to have to end up doing some math anyways, you could do cross multiplication and division like we've been doing. So 44 times D is 44D. And then you can go multiply 14 times 11. Skip a space. You will get 154. We're looking for D. We want D all by itself. I have to get rid of that 44, so I divide both sides by 44. Okay, D is going to equal 154 divided by 44. So I'm going to go do that math over here. Okay, so that's going to go 3 times 2. I'll put a decimal, bring it up, attach a 0, take it down. Goes 5. Yep, 5 times exactly. So our diameter here is 3.5, and that was meters. So you can go put that on the line. Our missing length is 3.5 meters for the smaller circle. So that's all. If you have any questions, be sure to jot them down, and we will talk about them tomorrow. Have a good night.